Right. Each time you want to prove that a quadrilateral is cyclic, you use the three converse theorem, which are represented in the diagrams respectively. So I'm going to concentrate on 2 points subtend equal angles on the same side as I try to come up with my tips. Right. Now, to show the hypothesis of this converse theorem, the starting point is to look up in the quadrilateral for the possibility of adding the interior angles of the triangles or using given information. Here is how to choose the two triangles, because as you can see, when you draw the diagonals of the quadrilateral, you come up with 8 triangles, right? The chosen two triangles should have common angle or angles, and they should include the angles you want to prove equal. For instance, I have triangle BCE, right, and triangle ADE, I can work with this triangle. The common angle is this one, which is vertically opposite. They are equal, right? Then from there, now if I am to consider my chord as AB, then the angles I want to show to be equal is this angle and this angle. And they are both inclusive in the triangles that I have chosen. So I have complied with this, right? Then the second example, now I would choose triangle ABE. ABE, this triangle, right? And triangle DCE. Right? Again, they have this angle is common, vertically opposite angle. And if I consider my chord as AB, that means the angle I'll be trying to show they are equal will be this angle and this one, right? If you consider your chord to be BC, that means the angle you'll be trying to show they are equal is this angle and this angle, right? Still, I've complied with those two tips. Common angle, include the angles that you want to prove equal, right? The last scenario would be if I could choose ADC, that's the triangle one. The other one is ABD. A, B, D. Right, as you can see, this triangle, they have the angles that are common. The first one, let me put it in blue. This angle is common in both triangles, right? The other angle which is common again is this one in both triangles. That means they will cancel out each other, right? And if I consider, in this case, my base is AB, that means the angles that I'm saying they are the same, that I want to show is this angle and this one. And I've complied with 1 and 2. Common angle include the angle that you want to prove to be true, right? That is crucial. Okay, given the diagram below, A, B, C, D is cyclic quad, TD is a tangent, AD parallel to BC, angle B3 is equals to angle B5, and TBS is a straight line. Prove that BWTD is a cyclic quad. The actual cyclic quad we want to show is this one. That's the quadrilateral we want to show that it's cyclic, right? But then before we think of anything, we need to identify from that red diagram the hypothesis of the converse theorem. And you realize that number 1 to 4 are the hypotheses obtained from the respective sides of the quadrilateral. That means each side you check whether does it subtend any 2 angles. If yes, then you write them down. So in this diagram or this problem, all the 4 are subtending. This is why we are having them as 4, right? So you can show any one of them, but I'm going to show all of them and see those that do not work, right? So as our starting point, we are saying to show that T1 is equal to W1, I have 2 choices. This is choice number 1, that I'm going to work with these 2 triangles. And let me draw them so that you see. BDT. Right? And then BDW. Right. So as you can see, B4, B3 is common. D2 is common, right? And the angles that I want to show is angle T1 and TW. It's within the respective angles. I mean triangles that I'm working with, right? So with that, then all what you need to do is simply to add the interior angles of the respective triangles. You get this in the first triangle, in the second you get that. Then once you have that, you apply the transitive property equating both sides. This is when you realize that now the D2, which is common, will cancel. Then B3, right? Then B4, B4. Look into the diagram. They are common, so they will cancel out each other. And then when you then look at it, we are going to remain with that. Then straight away, you ask yourself, where am I going? You want to arrive here, right? So that means I don't need this D1. I don't need this B5. All what it means now for them to disappear, they have to be equal because they are on the opposite side of the equal sign. Then I go back to the diagram and check how are they going to be equal. So you realize that D1 and B3 turn chord. Then B3, B5 given information. Then from the number 5 and 6 transitive property, you arrive at D1 is equals to B5, which is what I wanted. Then they disappear. And once they disappear, you now arrive at your hypothesis, which is what we have here. Then you conclude BWTD is a cyclic quad using the converse theorem. right? Choice number 2, still demonstrating the same thing. We still want to show that this angle is equal to that one, right? I'm going to choose another set of triangles, but you notice that in the diagram, the triangles I want to use this point, right? I'm going to call it F, because it was not labeled. I'm simply trying to come up with other different triangles. So if I go for the triangles that I've chosen, TFD, that means this one, right, TFD, then the other one, F, or rather, WFB, that is this one. Right. So those are the two triangles. So the vertically opposite angles that are equal is this angle and this one. They will eliminate each other at some point. Then again, those are the two. Again, the two triangles, they include what we wanted to show, right? So let us now see what happens. So using those two triangles, you simply then add them, equate to 180, then you apply the transitive property of equality, then you notice that, or you tell us that this is the same because they are vertically opposite. Then when you put them back, that means they will vanish. Once they vanish, we are going to remain with this situation. Of this situation, we look where we want to arrive. We don't want the B5, we don't want the D1. We then look into the diagram or information, you realize that the D1 is equal to B3 turn chord, B3, B5 is the given information. Then we can safely conclude that using 5 and 6, D1 and B5 are the same. Hence, they eliminate and we arrive at our hypothesis, which is what we wanted to show. And you conclude that BWTD is a cyclic quad using the converse theorem. Now, let's go to hypothesis number 2. We want B5 and D1. They are equal. So with that, all what you have to realize is if you want to put them into triangles, otherwise it's a very complicated issue. But then you look at the given information. The D1, of course, has a relationship with B3 turn chord. Then B3 has a relationship with the 5. And already we are also having B5 there. Then something will come up out of it. So you start by B5 is equals to angle B3, that is given information, right? Then D1 is equals to B3 turn chord, then transitive property, you conclude that B5 is equals to D1, which is our hypothesis. And you conclude that BWTD is a cyclic quad converse theorem. We go to hypothesis number 3, right? We want to prove that D2, this angle is equal to T2. They are subtended by BW, right? So here, obviously, as you can see, the triangles that are having equal angles are there. So we start from there, BTW. All right. Then the other one is BDW. BDW, this one. All right. Okay. Right. So they have common angles. You can see that W1 is common, then B5 is common. Those are the two angles that are common. This one and this one. Those are the ones I showed you initially that at the best you will see they will be there clearly to be used. So now you then sum the angles, right? When you sum the angles in the first triangle, which is triangle BTW, right? Is it BTW or it's BDW? BDW. Okay, then after that you do the same in the other triangle, BTW. Okay, then what you are going to do, apply the transitive property. You realize that we can have some numbers to cancel there, those angles that are equal. We say B5 and B5, then W1, W1, right? I don't think we have anything similar, no. Then the D2, B3, B4 is equal to T2, W2. This is what we now have. Now, if we have that, then the next question would be, what is it that we want? We want D2 and T2. That means this, we don't want this. We don't want this. So for them to disappear, it's only when they are equal. Then I'm simply writing here as indicating that they are equal, but I'm putting question mark to say, are they actually equal? If you look at them, you see that B3 and B4 is this angle, right? Then W2 is this angle. They can only be equal when we are considering this TD as the what? The chord subtending them. This is why I'm saying no, because quad BWTD is not yet proved to be a cyclic, right? So you have to be careful with this, because if you see that, then you think they are subtended by TD, yet that quad is yet to be proved, then it will be wrong. Therefore, the proof falls off. You could not have used this hypothesis. Then we go to number 4, hypothesis. You see that what we have been discussing is exactly what we have. We wanted to show that angle B4, B3 is equal to angle that, and they are subtended by this chord. It's not possible, right? Let us see how it is not possible. Again, we choose the triangles. We triangle BTW. BTW. Right, now with this triangle BTW, then BDW. Right. Right, you see that W1 is common, B5 is common, right? So they were eliminated at some point. So with that, then we write the interior angles of the respective triangles and equate them to 180. Then using the transitive property of equality, we equate them. Then the angles that are the same are the ones that are going to cancel out. You see, we have W1, W1. The other one is B5, 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 and it ends there. Then what is left is what is written here, right? Then with that now, what we want to arrive at is W is equals to angle B3 plus angle B4. So that means in that case, I don't need this on this side. I don't need this on that side. So we are now questioning, are these two equal? If you go to the diagram and try to check where they are, this is T2, right? T2 and D2. This is D2, right? They are subtended by BW. The fact that we have not proved that BWTD is cyclic, then we cannot use that to be true. Therefore, the proof falls off. So of the 4 hypotheses, only 2 were possible for you to demonstrate that the given quadrilateral is cyclic, right? The other one, you were not supposed to use them because you don't have enough information, as you have seen. But otherwise, what is key here is the use of triangles, how you select them. That is what is important. So, key takeaway from this presentation, proving a quadrilateral is cyclic using the converse, angles in the same segment equal. That's the idea of them being subtended by 2 points. Right, we are saying the starting point is look up in the quadrilateral. That is the quadrilateral that you want to prove that it is cyclic. That's where we're going to look up into, right? For the possibility of adding the interior angles of 2 triangles or using given information, right? We note that the chosen triangles should have common angle or angles, and they should include the angles you want to prove equal. That is important, because if you try to look at this diagram as it is, it's all triangles, so that if I want to prove this and this, one can say I'm going to use the triangle ABD and ACD. So as long as once you have done that, you can actually identify that this angle is common, right? And this angle is common, right? So once you establish that, then the possibility of using those 2 triangles is very high and you will be successful, right? So with that and the help of the given information, one can demonstrate that 2 points subtend equal angles at 2 other points on the same side. I hope this will help. Thank you so much for watching. Please like, comment, share, and subscribe.